In this video, we will dive into a new study that may solve the mystery and reveal the true nature of the ancient galaxies. One of the most surprising and puzzling discoveries that JWST has made is that some of the earliest galaxies were very bright and massive, much more than expected by the standard model of cosmology. How did these galaxies become so luminous and heavy in such a short time? And what does this mean for our understanding of galaxy formation and evolution? Let's also discuss how this study challenges our current theories and opens up new possibilities for future research. So watch this video until the end and get ready to witness the dawn of cosmic light. To detect these galaxies, scientists used Webb's near-infrared camera, or NIRCam, which is designed to capture images of the infrared sky with high sensitivity and resolution. It can also use special filters to isolate specific wavelengths of light that correspond to certain features of galaxies such as hydrogen emission lines or stellar populations. By using these filters, scientists can estimate the distance, size, mass, brightness, and star formation rate of these galaxies. One way to tell is by looking at their redshift, which is a measure of how much their light has been stretched by the expansion of the universe. The higher the redshift, the farther away and older the galaxy is. For example, a galaxy with a redshift of 10 means that we see it as it was when the universe was about 500 million years old. So scientists used Webb's NIRCam to search for galaxies with redshifts between 9 and 12, which are considered to be from the cosmic dawn epoch. The question is, what type of galaxies can the Webb telescope see? Essentially, Hubble can see the equivalent of toddler galaxies, and Webb telescope will be able to see baby galaxies. One reason Webb will be able to see the first galaxies is because it is an infrared telescope. The universe, and thus the galaxies in it, is expanding. Using this method, scientists identified 14 candidate galaxies from the cosmic dawn, which they named JWST, Early Release Science Galaxies, or JERGs. These galaxies were very bright and massive for their age, with luminosities ranging from 10 to 100 times that of the Milky Way and masses ranging from 10 billion to 100 billion solar masses. These values were much higher than predicted by the standard model of cosmology, which assumes that galaxies grow gradually over time by merging with smaller ones. How did these galaxies become so big and bright in such a short time, and were they really as large and steady as they appeared? To answer these questions, scientists use computer simulations to model the properties and evolution of these galaxies. They used a code called Blue Tides, which is one of the largest cosmological simulations ever performed, covering a volume of about 400 billion light-years across. It can simulate how dark matter, gas, stars, black holes, and radiation interact in the early universe, and how they affect galaxy formation and evolution by comparing the simulated galaxies with the observed ones. Scientists found that there was a possible explanation for why these galaxies were so bright and massive. They were not large and steady, but rather small and bright because of bursts of star formation. In other words, these galaxies were experiencing episodes of intense star formation that lasted for a few million years, during which they produced thousands or millions of new stars per year. These stars were very hot and luminous, emitting a lot of ultraviolet radiation that ionized the surrounding gas and made it glow in infrared wavelengths. This made these galaxies appear much larger and brighter than they actually were. But how do scientists know which galaxies are from the cosmic dawn, which occurred about 540 million to 770 million years after the Big Bang? The first step to solving the mystery of the early galaxies is to find them and measure their properties. This is not an easy task because these galaxies are very far away and very faint, and their light has been stretched by the expansion of the universe into infrared wavelengths. However, this finding also challenges the standard model of cosmology, which predicts that star formation should be slow and steady in the early universe because of various feedback mechanisms that limit it. For example, supernova explosions can blow away gas from galaxies, preventing it from forming new stars. Black holes can also heat up gas with their jets and radiation, making it less dense and less likely to collapse into stars. However, these feedback mechanisms may not have been very effective in the cosmic dawn epoch, because supernova were rare and black holes were small. Therefore, star formation may have been more rapid and chaotic than previously thought, resulting in bursts of star formation that made some galaxies very bright and massive. So how do these galaxies compare with other types of galaxies that Webb has observed or will observe in the future? One way to compare them is by looking at their infrared colors, which indicate their temperature and dust content. For example, galaxies that are very hot and dust-free have blue colors, while galaxies that are cooler and duskier have red colors. The JWST have very blue colors, which means that they are very hot and dust-free. This is consistent with JWST's high star formation rates and low metallicity, which means that they have not had enough time to produce and accumulate heavy elements in dust. Another way to compare them is by looking at their sizes and shapes, which indicate their structure and morphology. For example, galaxies that are large and round have smooth profiles, while galaxies that are small and irregular have clumpy profiles. The JWST have very smooth profiles, which means that they are large and round. However, this may be an illusion caused by their high brightness and the resolution of Webb's Narcam, which can only resolve objects that are larger than about 1 kiloparc across. In reality, these galaxies may be much smaller and clumpier than they appear as suggested by the simulations. In contrast, there are other types of galaxies that Webb has observed or will observe in the future that have different properties from the JWST. If we put it as an example, then there are galaxies that are very red and dusty, which means that they are cooler and dustier than the JWST. These galaxies may have formed earlier and may have experienced more feedback from supernova and black holes, which enriched them with metals and dust. They may also be more massive and stable than the JWST, and they may host more massive black holes at their centers. James Webb can observe these galaxies with its mid-infrared instrument, or MIRI, which can detect longer wavelengths of light than NIRCam. Another example are galaxies that are very faint and distant, which means that they are closer to the beginning of the cosmic dawn epoch. These galaxies may be the first ones to form in the universe. What are your thoughts about this latest discovery? Tell us in the comments. To stay updated, please subscribe to the channel and turn on the bell notification. Also, like and share our channel. See you soon with such informative videos. Till then, thank you for watching this video until the end.